Let's look at a specific example of population, sample, statistics, parameter. And so here's a situation where we're curious about the proportion of 18 to 24-year-old residents in California, whether they will vote in the next election. And so we call 50 numbers, randomly call 50 numbers who are 18 to 24 and ask them, are you planning on voting in the next presidential election? And so in this setup here, we have our sample, which are the 50 randomly selected residents. The population would be all of 18 to 24-year-old California residents. And you can see in the diagram here, you're going to select 50 from across that population. When we get that percentage for those 50 people, that would be a statistic. Now, what we're hoping is that statistic gives us or describes what the parameter is, or the parameter of interest, right? Which is really the percent of proportion of all 18 to 24-year-old residents who will vote. But since we don't have the ability to ask every resident, we do a sample, calculate a statistic, and hope, right, with some level of confidence that that statistic describes the parameter, which in general then would describe the population, right? Let's look at another one. Oh, I want to look at, this is an interesting question. It says the presidential elections happen every 4 years. What is the actual turnout? What is the data tell us? I pulled this off for the most recent data, at least from the 2018 elections. And you can see by race, you have the percent of eligible voters who voted. And so you'll see in 2014, pretty low numbers compared to 1990 here. You can see some trend, kind of level off. But for some reason in 2018, which again is just which would be a reason why we do statistics, it would be, wow, something happened from 14 to 18 to increase participation. Overall, still, people in our country don't vote, right? You see only 45% down for Latinos and Hispanics and Asians down to the 20s in 2014, and everything increased. But we don't vote, and that's it. And guess what group votes the least amount? It's going to be 18 to 24-year-olds also. That may be you guys. We'll see. Here's another question here just to practice this idea. And you can see the difference between a population and a sample. And then we use the samples to get a statistic. And then that statistic, we hope, describes the parameter. And so in this case, all the patients who take the medication of the population, the 4 that we sample is the sample. And we hope that that would describe that population. Is again one of the reasons why we do statistics. If we were in class, we could have this discussion, but I really do want you thinking about what topics from the world, right, do we want to discuss in this class. You may get a chance to do some data collection on that. Let's finish this first section with another term here, sampling frame. And this gets confused with sample. Think about, you have a population of interest, right? All California residents, right? 18 to 24 per se. And then a sampling frame is this group, right? As it says here, a good sample must be random. Our sample can only be representative of the group from which we sample. So we're hoping that somehow the sample we have represents the population, right? So if we're interested in learning about a population, the sample should be representative, should be related to it in some way. Can only be representative of the group from which we sample. We call the group the sampling frame. It is ideal to have a sampling frame to be the entire population, but sometimes this is not true. We hope that the sampling frame is the same, or at least representative. So we end up having to take, we're going to take a sample from a group within that population, right? And we're hoping that that sampling frame is representative of the population, then our results. Here's an example that you can look at here. Looking at the difference between the population, which all Santa Ana College students, and then you have a sampling frame, which were, in this case, all the students in the 25 selected classes. Since we couldn't interview everybody, we took a sample of classes called our sampling frame. In this case, it's not the whole population, but we're hoping that it's representative. See, it's within the whole group. there's my 25 classes, and then the sample would be all students selected from the 25 classes, right? And that's 10 per class. So we're hoping that would be representative so that we could learn about our population of interest. And we finished this section with introduction to different types of data. So once we're going to sample, what do we do when we sample? We collect data. There are two types of data to collect, categorical or quantitative, at least in this introductory statistics class. You can see the difference between them. Keep in mind as we collect data, the type of data, categorical or quantitative, right? Or that's called qualitative also, or numerical for quantitative, determines the type of analysis we're going to do and the types of tools we could use to describe data. And so I want to make sure you're aware of that. That's why it's very important to be able to distinguish between these two. And then from the example, age and years is quantitative, right? If you ask someone how old they are, what political party, that's qualitative or categorical. Your social security number is qualitative also, or a categorical, since a social security number is not really a number, it's just a label. Like a jersey number would be another one, right? Another example of them. But we're going to end up talking about this a lot more in this class because it really is essential. And so I think we'll stop there.